Hello everyone, today we're going to be going over the Enteropluri, specifically how to operate the Enteropluri codebook and the API codebook, and how to properly interpret an Enteropluri. On OneDrive, there will be pictures of unknowns, and they will have either the API strip or the Enteropluri strip. This is the Enteropluri strip right here. These are the different wells. This is an uninoculated Enteropluri. And what you're going to have is you're going to have here an unknown number and a temperature. That's mostly for us, but it's also for you since you're identifying your unknown. This is the same unknown that you had last week. And you'll have different tests that are going on. When we give you your Enteropluri, assume that we've added in all the necessary reagents. When we get to the API strip and we're doing the nitrate reduction test, I will code out which reagents have been added. You will need to know that as well for proper reading. For things like the catalase test and the oxidase test, use the same results you had last week. It's the same unknown. Now, when you get the Enteropluri, you're going to get something similar to this, where you're going to go through the different tests, and each test is going to have a positivity code. If it's positive in group 1, for instance, for the glucose, that's weighted at 4, 2, and 1, then 4, 2, 1, then 4, 2, 1, and so on. And what you do is you add in across. So this one right here is a positive, positive, negative. So that's 4 plus 2 plus 0, which is 6. 6 here. Since there isn't a positive reaction, it's a 0. You do not subtract the number. It is simply a 0. So the version for this is 66026. You then need to go to our book, which is here, or PDF. There is a PDF that's made available to you on Blackboard. You can use that as well. Or both. Your choice, really. The API is a very similar thing. Here is the full API strip. This is full positive tests. Same thing with the triad, only this time the far right one is the 4, where the left one is the 1. So in this case, it's 4, 2, 1, which is 7, and then we get our code to what that is. And our 7-digit digital code is 7031645. Now then, we are going to do a hypothetical here. And this is so that I can show you how to use these books. Let me pull up my annotation here. Our API code, as I am really bad at this, is going to be 0044040. Our Enteropluri code is going to be 41100. Nobody has these. Well, may not have these. When we look at the Enteropluri, I'll explain what I mean by that. But this species that I have taken is a Shingella species. We do not have Shingella in our lab. So I have identified an unknown with these codes. So let's go to our Enteropluri codebook. Now I'm going to pull up the PDFs for this. And the reason I'm pulling up the PDFs is because there's a decent chance that that's what you're going to be using. So let me pull up the book here. So here is the PDF of the Enteropluri test. Make sure you're seeing this. There we go. There we go. This is our Enteropluri codebook. This goes through how to use the Enteropluri as well as the reagents that are necessary. We don't have to worry about purchasing reagents. That's my job. I actually quite like it. Going through these, it gives you a description of what each one does, as well as what a positive and a negative looks like. And once again, it goes through the description. Notice how this is almost identical to the one that I gave you, but this does show you what we have in terms of errors here. This code that they give you for 0007, it can be read as Provincius Duarte, Proteus vulgaris, and Proteus mirabilis, but it really does depend on what you have. So you should do confirmatory tests, and there's ways of doing that. If you want to make sure that it's a Proteus species, the easiest way is to grow it on Hectonin. And if you get black colonies, it's a Proteus species. Provincia doesn't get that, but Hectonin does. So think about ways of, when we're going through these, ways of identifying out these individual species with some either things that we find odd, in the case of Proteus, actually reducing sulfur on Hectonin, which is typically a result of Shingella, but because we know it's not Shingella, it has to be something else. It's like that, so Proteus works. Or as we get to our Shingella and how we would tease out that other bacteria. So once again, I'm going to annotate so we have our number here. Our number we're going to be looking up is 41100. That's our number. So keep that in mind as we go forward. So we're going to scroll down here. After we get past all of this, we start getting into numbers. And we're looking for 411. Which is probably towards the midpoint. All right, 411. 00 is right here. So now, what do we have? We might have an E. coli, we might have a Panotea, or we might have a Shingella. How do we know what this is? Well, now we have to start thinking. Do we have an unknown that's Panotea? Have we looked at Panotea? Not really. Shingella, maybe. E. coli, we've worked with that. How would we tease out E. coli from Shingella? EMB auger. E. coli is obvious on EMB auger. So now that we have this, if let's say your unknown came up with this, once again, your unknown is this code. How would you choose it to be? How would you know not to use Panotea? We know it's not Shingella because Shingella is a. I just told you that we don't have Shingella as our unknown. It's also a human pathogen. So how do we go about teasing this out? Well, we think, or we do other additional tests. I don't know enough about Panotea to know exactly what to do offhand, but I would go to my Bergey's guide and see what chemical tests it has and then tease them out between E. coli. Or just grow E. coli on EMB auger. In your case, if you get to a identification of something that is, and I haven't looked at this entire book, so I don't know exactly what we're going to get. That is, well, since Yersinia is here, let's go with an extreme example. Let's go with you get the choice of either Shingella species, Yersinia pestis, and E. coli. For those of you that don't know, Yersinia pestis is the bubonic plague. We don't have that. We don't have Shingella, therefore it has to be E. coli. I don't know if that's actually somewhere in here. That's just an example. But part of this identification and part of your rationale is also thinking, does this make sense? And if it makes sense, go with it. If it doesn't, if you get to the point where you have two different bacteria that are similarly sensical. So you can't identify them. That's perfectly fine. Other tests would need to be done, which are beyond the scope of this course. But that's the Enteropluri codebook. The Enteropluri codebook is nice because it's easy for you to read. It's in a nice font, and it was designed specifically for a PDF. Unlike the API codebook, as you can see, is in a terrible font. It's basically a scan that was created of the codebook itself. We do have the formal codebook as well, right here. We have 2 copies of this. We have 1 copy of 3 copies, excuse me, of the Enteropluri codebook. And you are welcome to come into the lab and key out your bacteria if you wish. Now, once again, we have a specific code. And our code this time is 0044040. So let's take a look at what that will be. Now, unlike the other book, you will have to, possibly flip this or flip your tablet or whatever you're reading it on, since it is simply a scan. It's not a formal PDF. But let's see if we can find that bacteria. Notice how this time also we have typewritten rather than formally PDF. This is another indication that it was just a different type. And we're looking for 0044. So 002. Now, this is an example of, I paused it and I did some digging on my end. This is an example of properly writing down your code number. I didn't properly write down my code number. There was an extra 0. So it's actually 0004400, which is this right here, which is, in this case, Shingella dysenteriae or dysentery. Enteric bacteria. So now we know that we have a Shingella species or an E. coli species or Shingella dysenteriae. For your lab report, you compare the two. And you go and ask yourself, does that make sense? Is Shingella dysenteriae possible? Yes. It's an enteric bacteria. It works with the API, it works with the Enteropluri, so it does work. And we go from there. Keep in mind that when you look at these code books, they are specifics. So let's go look back at the Enteropluri, and it says it right in the name, Enteropluri. But keep in mind that this is an identification system for the Enterobacteriaceae. So would we expect certain bacteria to not be able to be coded out if, say, they were Streptococcus viridans? No, because Streptococcus viridans is not an enteric bacteria. So if you have an issue with keying out your bacteria, ask yourselves, do I think this is an enteric? If you have a gram-positive rod, ask yourself, does this make sense? And if it doesn't make sense for your lab report, it is perfectly fine for you to say, I don't know how to continue this. But I do know that the API and the Enteropluri test will not work because our APIs and our Enteropluris are only for enteric bacteria. And I don't think I have an enteric bacteria. And this is why. And you state your reasons why you don't. That is a perfectly valid explanation. That would be a great discussion. It's almost like that would be a great quiz question. Foreshadowing. So keep that in mind, that both the API and the Enteropluri, you are looking just at enteric bacteria. And if you don't have an enteric bacteria, then you're not going to be able to properly key out the bacteria, even if you get results. Or if you do get results, it will be the wrong thing. So once again, if you key yours out and it's E. coli, but knowing that E. coli is a gram-negative rod and you have, say, a gram-positive coccus, does that make sense? Not really. So that's the introduction to the code books. Good luck. I hope you all have fun finding out what your bacteria is. I certainly do. I always enjoy these. And have yourselves a good day.